Okay. So,
Yes.
uh, so tell me, what is distillation column?
Distillation column in which the crude oil is separated into the different products such as petrol, diesel, kerosene, heavy gas oil, and residue. So in which the temperature is main gradient in the distillation column.
Okay. So, what is the basic principle by which distillation works?
Basic difference is the volatility of the product.
Okay. What is volatility?
Volatility is the tendency to evaporate of the product.
Tendency to?
Evaporate.
Acha, okay. Tendency to evaporate the product. Okay.
Yes.
So tell me, what is leaching?
Leaching. Yes, ma'am.
Mm.
The extraction of the any metal from the solid using any solvent is called leaching.
Mm. Once again, can you repeat?
Extraction of any metal or solid material uh, using a solvent is called leaching.
Leaching. Okay. Yeah, good. Can you give an example in your daily life where leaching happens?
Leaching, yes, ma'am. We can washing of our cloth.
Washing. Yeah. Okay. Yeah, good. Good example.
Yes.
So tell me, see. So distillation, you have said it depends upon the volatility. It actually gets separated into different components, right?
Yes, ma'am.
There are like so many basic components are petrol, kerosene, and diesel. Okay.
Yes, ma'am. Yes, ma'am.
Tell me which one has which based upon the volatility, rate
Yes, ma'am.
these three, 1, 2, 3.
Based on
Which one is very volatile and which one is less volatile?
yes,
Petrol, kerosene, and diesel.
petrol kerosene. Yes, first one is petrol.
Okay.
Petrol have high volatility.
Mm.
Second one is kerosene, and third one is diesel.
Are you sure?
In kerosene and diesel, I'm little bit confused.
Okay, let's move on to the next question. Okay, see, this distillation column works on this McAptili method, and you need to calculate based upon graphically, as everybody is aware of. In that, we know a feed line is very much important to draw. Okay,
Yes,
so
yes,
tell
ma'am.
me, in feed line, what Q means? What is the formula of Q? And what if the Q is equals to 1? Then what is the feed? How it represents what is the feed?
Yes, ma'am.
Hmm.
Yes, ma'am. Q tell us about the nature of the feed.
Okay,
Am I
yeah.
audible, ma'am?
Yeah, you are audible, but yeah,
Yes.
video got paused. Now it is okay.
Yes.
Tell me. Okay.
Q line tell us about Q value tell us about the nature of the feed, and accordingly we feed in different tray in the column. So
Okay.
if the Q value is 1, then the feed is liquid at boiling point.
Liquid at boiling point.
Liquid, yes, ma'am.
Are you sure? Liquid at boiling point means? Okay. Tell me what is the formula of Q?
Formula of Q is 1 minute. The amount of liquid in the feed upon total feed.
Amount of liquid. So now I said Q is equals to 1. So what does
Yes.
that mean?
That means the feed is totally liquid. That's the.
Just it is liquid only.
Yes.
Okay. So you know this law of diffusion, right?
Yes, ma'am. Yes, ma'am.
Tell me law of diffusion, main basic formula in liquids.
In liquids. The fixed law of diffusion is the main formula in which the mass flux is proportional to the concentration gradient of that liquid in the particular distance.
What is okay? So basic difference between diffusion between liquids and gas. What is how the formula changes for liquids and gases?
Okay. In case of liquid, the partial pressure uh, and is used to calculate the flux. But in case of liquid,
Hmm.
we use the concentration.
Okay.
Yes.
Okay. So all this laws of diffusion works at the film of the layer or inside the bulk material also.
Can you repeat, ma'am?
All this laws of diffusion works
Yes.
at the interaction of two different phases, or does it happen in a bulk phase also?
Yes, it happen in the bulk phase also. First,
Hmm.
it comes from one bulk phase to the interface, and then
Exactly.
interface to the second phase.
Okay.
This-
So in this formula, we have a constant term, right? A
Yes,
constant term. What is that constant?
mass transfer coefficient.
Okay. So mass transfer, define mass transfer coefficient.
Mm, Mass transfer coefficient is so the nature that how easily the diffusion will take place.
Okay. So it explains how easily the diffusion takes place. That is what you are saying, right?
Yes, ma'am.
So tell me, so
Yes,
in an
ma'am.
industry, we have so many equipments, and
Yes,
distillation is also one of the equipment. Okay.
yes, ma'am. Yes, ma'am.
For a distillation column, we have two important heat exchangers at top and bottom. What are they?
Yes. One is reboiler
Hmm.
and above part is condenser.
Other part is condenser. So in a
Yes,
distillation column,
yes, ma'am.
temperature increases from top to bottom or decreases from top to bottom.
It decreases from top to bottom. Sorry, it decreases from bottom to top.
Decreases from bottom to top. Are you
Yes,
sure? Why it
yes.
decreases from bottom to top?
Because in the reboiler in the bottom of the distillation column, so
Hmm.
the highest temperature at the bottom,
Hmm.
and subsequently the temperature reduce
Okay.
in the above
So
part.
tell me what happens to the pressure? Will it decreases from top to bottom or increases from top to bottom?
Pressure is increased from bottom to top because the vapors generation increase in the top of the column. So the higher gases will contribute to the high pressure.
So you are saying both temperature and pressure increases from bottom to top.
No,
That
no,
is what
ma'am. It's reverse.
it's
In,
reverse.
yeah, the pressure is higher in the bottom.
Hmm.
Sorry, the temperature is higher in the bottom, whereas the where and yes, both temperature and pressure are higher in. Sorry, temperature is higher in the bottom and the pressure is higher on the top.
Temperature is high at bottom and pressure is high at top.
Pressure is higher on the top.
Are you sure about your answer, Prithviraj?
Yes, ma'am.
You don't want to think again once?
No, ma'am.
So, okay, this is the last question. Okay.
Yes.
So tell me what is reflex ratio?
Reflux ratio is the amount of we send the amount of over product return to the distillation column. That how much amount we again transfer to the distillation column from our output.
Okay. Okay. Thank you, Prithviraj. Okay.
Yes.
Uh, you have answered questions very good. And petrol, kerosene, diesel. It is petrol, kerosene, diesel. Okay. Volatility of this one is very high, and that
Yes.
is okay.
Yes.
And when I asked you about Q is equals to that formula also you have said, right? It is liquid at its boiling point means it is nothing but saturated feed, saturated liquid.
Saturated.
Saturated.
Yes.
That is
Yes.
the how you need to explain because liquid at boiling
Yeah.
point is a not correct term. You
Yes.
already
Yes. Yes.
know
Yes.
that thing, right? Saturated feed, saturated word you need to use.
Saturated. Actually, I
That's fine.
didn't remember that term
Are you?
at
It's
that
okay.
much.
It's okay. It's okay. It's okay. And pressure and temperature, you got confused so much. See, I'm not
Ah.
expecting the answer from you. I don't want the correct answer. I want the confidence by the way you are presenting. Okay, ma'am, from top to bottom, You said for temperature, very good. Top condenser is there, bottom reboiler is there. The boiler
Yes.
actually generates heat, so bottom temperature is very high, and as it goes on to top, the temperature decreases. That is
Yes.
that if you explain in that way, that is good. And when I asked you about pressure, it is a constant volume basis, right? Because the volume of the column is constant. So at
Oh,
constant volume, P is directly proportional to T. Basic,
okay.
like
Yes.
our
Yes.
ideal gas law. So
Yes.
P is directly proportional to T. So if temperature increases, pressure also increases. That way you can relate, and you can simply say there only. Like if you didn't get any point at that point of studying, go to the
Okay.
basics. We know now at constant volume what happens, at constant pressure what happens, at constant temperature what happens.
Yes.
So based on that only you can move on. And reminding other questions also you have explained good. Leaching, good example, good explanation also. Study about
Yes.
extraction also. All types of diffusions you explain, like liquid gas, gas, solid liquid, solid may it will not happen until and unless if you're talking about heat transfer. Okay,
Yes.
so
Yes.
these points you can actually work upon. And mixable phases, immixable phases, obviously that is also important. Work
Yes.
upon that thing also. As they're preparing for HPCL, I don't think this much depth questions they'll ask.
Yes.
I kept it very depth because who knows, like if they ask, then it is always better to be prepared. So I asked.
Yes. Yes.
Distillation you study more because industry may about distillation, obviously the equipment will be there.
Yes. Yes.
We
Yes.
will be operating every day, so
Yes.
they know what are the operating pressures, temperatures, and etc. So that is why different types of crude also you just study. And also
Yes.
HPCL, visit the HPCL website and see where the crude is being like exported from,
Import.
imported to us. Well, exactly.
Yes. Like Russian crude, which is two types,
Exactly.
Sukhoi crude and one
Yeah.
is yes.
So, like, see, go through these points also. Then it will be helpful. Like when you are pointing out, then you will know they'll know that you know about HPCL very much. So
Yes.
yeah,
Yes.
these points and Q feed line. That thing you see what are the terms like greater than one, equals to one, less than one, equals to zero. All those things. Okay.
Yes.
Overall, you did good. When you didn't know a little bit of that thing will be there a little bit, but that also will try to overcome in the next videos. Okay.
Yes. Yes,
Yeah.
ma'am. Okay.
Bye.
Thank you, ma'am.
Yeah. It's okay.